Okay, so we've already talked about a couple series, harmonic, geometric, and telescoping. Now, real quick, let's add another series to that. Remember that harmonic series, that 1 over n? Well, that was 1 over n to the first. If I have 1 over n raised to the p value, where p is the power, power makes sense, if p is greater than 1, if p is greater than 1, then this series is going to converge. So right here, this is the test. If it's greater than 1, it's going to converge. If it's less than or equal to 1, it's going to diverge. So unlike the last divergent case, where we can only say it diverged, in this case, we can test for sure, does it diverge or does it actually converge? So that's a super easy test to take a look at. So for example, 1 over n squared, definitely going to converge because that value larger than 1. Now, here's another test. So we have the p-series test, we have the integral test. The integral test is nothing more than if the integral of that series converges, then the series converges. Now, it does make sense that an integral sign is really just another version of an S or a sigma. So what we do is we say the series is basically an integral, and if this converges, then I can guarantee that this converges. So once I know this converges, this will converge. There is a caveat. Just because I know the integral converges does not mean the number that integral converges to is the number that the series converges to. So they will both converge or both diverge, but the number itself is not particularly meaningful. So that's integral test and a p-test. Now let's talk about remainder. Well, what's a remainder? It's the leftovers, okay? So if I want a remainder, all it's suggesting is I can estimate it from the integral test by integrating beyond what I'm looking for. So let's assume I want the 10th partial sum of some summation a to n, or a sub n. So I'm going to go from 1 to 10. That is the partial sum. Well, but that's not the end of it. There's more stuff on over here. So what would the remainder, what would the rest of it be? And the answer is, well, why don't we just take the integral from, since we left off at 10 here, let's start at 10 and take it all the way to infinity of a sub n. And if I find that integral, that's going to allow me to find a formula that gives me the remainder of this series. So you have the partial sum and the remainder. So all it's suggesting is that you can have the partial sum and the remainder, and that remainder is going to be a pretty good estimate of what's left. All right. So estimating the value of a series, let's do an example here. In this particular case, I have 1 over n cubed. First of all, does it converge? Well, is it a p-series? Yes. Is the power greater than 1? Yes. So it is going to converge. Now, why don't we care if it diverges? Well, if it diverges, what's the remainder going to be? Well, see here, if it diverges, it's going to infinity. So no matter what my partial sum is, the rest of it is still going to be infinity because it's diverging. So we only care about remainders when we're converging. So first of all, let's calculate S sub 10 and estimate the error. So what do? We actually have come up with S sub 10. There it is. And so the remainder would be if I pick it up at 10 and go to infinity. So I'm going to take the integral from 10 to infinity of 1 over x cubed. And I'm going to integrate it, boom, 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 boom. And of course, it's an improper integral because I cannot have a bound that is infinity. So if I can't have a bound of infinity, what I can do is I can take the limit as the bound approaches infinity. In which case, this is going to be left over. And so we have, in short, the remainder is going to follow this pattern. So what is the remainder? Well, it's actually pretty easy. All I have to do is, since I have the 10th partial sum, I plug in 10, and that gives me that for my remainder beyond the partial sum. So I have 1.197 dot 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 plus 0.005. Oh, I'm sorry. If I plug in 10 cubed, yes, the error is going to be 0.005. Okay. So in this case, find the number. So how far would I have to go to get it within 0.001 rather than 0.005? Well, the nice thing is I already know how to find the remainder. So all I have to do is set it greater than what I want the remainder to be, 0.001, and solve. So I set it up, I solve, and I come up with 22.36, which is 23 terms. So that's finding the remainder or finding how far I have to go to keep it within the range of a certain remainder. Okay, so let's pause here and we'll go to the comparison test.